So in this activity, have chosen to use the sketches instead of the patty paper. I feel the sketches gives us a better opportunity to explore a lot of answers more quickly than the patty paper does. So in the sketches, I'm going to back up to the previous activities, 7.2 day 1, where we're exploring side, side, side. And so the blue sides, the green sides, and the red sides are the corresponding sides. And if I click here, I can look at angle measurements as well. So right now, all the angle measurements are the same number. So if I move the shape around, I'm trying to envision here is, do I get the same shape every time? Is it possible to get shapes to be different? I can always check angle measurements to see if I'm getting the same angles. I got 131, 23, 26, same angle measurements. So as I'm moving the shape around, the measurements I'm getting each time seems to be the same measurements. The shape definitely seems to be the same shape. So side angle side is one of those patterns that visually appears to work. The angles part of the menu here supports that we have similar triangles. So we're going to accept side, side, side at this point to be one of those patterns that works. One of the patterns I didn't ask you to explore, but we did in class on Thursday, was side, side angle. So we have the green to blue to the angle, the green to blue, the green to the blue to the angle. So both are showing side, side angle. So right now if I put in the angles, all the angles are the same, the shapes appear to be the same shape. Here if I go to here, angles appear to be the same. And so I was trying to get students to do, if you were not in class, 136, I was trying to get a combination that didn't work. If you'll notice here, the angles no longer are the same. I got 136, 124, I got 39 here, and I got 50, and the smallest angles are at the top. So these two angles here and these two angles here are not the same angle measurement. So again, the goal here is to try to get them so they're different. And can we do that? Right now, they appear to be the same, but we're able to get a combination that didn't work. Here's another combination that doesn't work: 71, 75, 91, 95. So we got a couple different cases here where side-side angle just doesn't work always. So that's the pattern that we didn't work as congruency, because it was possible to get two different triangles. And same thing with similarity, it doesn't work as a pattern. For side angle side, try to get the triangles to not be the same. So I'm going to go ahead and click on the angles here, same measurement. Stop it here somewhere, measurements are the same. So as we investigated this, if you were not in class, as a class, we could not get a case where it didn't work. So side angle side was one of those that just always seemed to work. Side angle, so the side that's included with both angles, that's the red sides, makes it an angle side angle. And again, we spent a lot of time just trying to get the triangles to be different, and wherever we stopped at, the measurements continue to be the same. Now, one of the things that in this pattern here, and then the next one, which was angle side. So we got the two angles followed by the blue side. And these two patterns, they both work as similarity patterns. There's no way to make the angles a different set of measurements. I both got 108s, 38s, and 34s. If I move it again, I got two 35s, two 72s, two 73s. The measurements end up being the same measurements. The shape stays the same. It's just different scaling. But this problem here and this one here, what the packet was trying to get you to understand is, does it really matter what the side length is? So I'm going to kind of scroll down to that discussion. So in here, I'm asking you to place a point along here, and you place it anywhere you like, and to come back to that 65-degree angle, and other triangles are always similar. Same thing here. If I put in, I can choose anywhere along here and come back with a 77-degree angle, and the triangles end up remaining similar, same shape, same angle measurements. And the question is, does it really matter where I place this point at, whether it is an angle side case or an angle side angle case? And the answer we came up with is it doesn't matter. So because it doesn't matter, the side part of the pattern just gets removed. And this actually is just an angle pattern. Where side, angle side, it is critical because we have two pairs of sides or three pairs of sides, and the scale factor has to be the same between the different pairs. Here, there's just one pair. So if the scale factor is 2, okay. So, if it's 3.5, it means the one triangle got bigger than the previous one. But in terms of the pair of sides, it doesn't matter what the scale factor is on the one pair. The triangles remain similar as long as the angle pairs match up, which again, just two pairs need to match up. Because if two angles are the same, then the third angle pair has to be the same based on our triangle angle sum rule. So this one's called an angle pattern. So so I covered all the patterns, and I included in here side angle, which doesn't always work. There is one pattern from our congruency that we haven't explored here, and that is hypotenuse leg. So there's some problems here at the end that you're supposed to have finished up, which is problem number 15 and 16. So hopefully you've done that. I will be asking you to submit the packet, and I will be looking definitely at problem 15 and 16, since some of you may have chosen to complete the activity using the online sketches. In addition to that, if you go back to last Thursday and open up the one sketch, take a moment and explore hypotenuse leg. So, for example, and I would turn on the angles. I would make angle F maybe, for example, a 90-degree angle. And if I make this a 90-degree angle and connect this angle to this angle, for example, it'll automatically will make it in both 90s. And if I connect the leg, for example, and the hypotenuse, so the 7 and the whatever that length is, those are the longest sides are opposite the 90-degree angle. And then this angle side here is between the two bigger angles, which is right here. And so I have what is a hypotenuse leg situation. And it appears, if I check the angle measurements, it appears the angle measurements remain the same. Now, if I move the one triangle, the other one also moves. But the issue is it doesn't remain 90-degree angle. So anytime on the hypotenuse leg exploration, you have to readjust the angle to get it to 90 degrees. But when you do that, are you getting triangles that appear to be similar? So we got 24, I think it was like a 24 there, and we got 90 to 66s, and so the angle measurements appear to be the same. The shape appears to be the same kind of shape. So why don't you go ahead and go back to that sketch and spend some time exploring the hypotenuse leg and make a decision. Can we call hypotenuse leg also a good similarity pattern? So that's it for lesson 7.2, day 2. If you have any questions, let me know.